opportunità. Vorrei ringraziare il Tenente Generale Savastrone, Chandra Cardinali, Maggiore Generale Giuliani Eletti e Molteni, excuse me. As the General said, I want to speak in English. I'll speak in Italian at the bar as long as you want, but I don't trust myself in the briefing. So what I want to talk about, I was honored to give this briefing 3 years ago and talk about the future of vertical lift 3 years ago this month. And I've looked back at that to kind of compare where we were and where we're at now. And the one thing that hit me today, at that point in time, only Augusta and Boeing had 1 or 2 slides on tilt rotors. Every single presentation today has said something about them, so that shows how far we've come in regard to that technology. So what was going on in 2012? At that point in time, we were starting to hit budget cuts in the United States. They were hitting economic austerity here in Europe. And then what that has driven was with a reduced budget, it drove a lot of incremental developments. You can't afford to buy something new, you have to modify what you have to make it more capable. There's also been less competition because of that. I think you're already seeing that even with the Lockheed-Sikorsky merger is a good example of that, of a market that's starting to become less fragmented. What was of note at that point in time was, right now I know we're in the heart of the Italian Air Force. You're on 5th generation fighters. We're on 3rd generation rotary wing. The development from, and the R&D, the research and development from the United States DoD and DARPA has not, it's about 16 to 17% for vertical lift, and the rest of it goes to fixed wing. So that shows you some of the technology gap. That hasn't changed since 2011, 2012. With the reductions, I mean, Andrea and Nativi and I had a discussion with the significant budget that the U.S. has with DARPA. That is a big propeller, not just for U.S. industry, but world industry, because it drives a lot of developments for the entire market worldwide. But the reality is, vertical lift only gets a small slice of that pie. My presentation is going to try to frame this discussion in the context of the Boeing portfolio, what we have now, where we're at, where it's come from, and where we're going. So bear with me. Also, I apologize for the number of slides, but I'll try to go through them quickly, and some of them is because, again, I was an infantryman, so pictures are better than words. If I speak too fast and you don't understand something, please let me know. I'll try to speak clearly, but it's going to be in English, and I know that for me, being from Alabama, that's the second language. Okay, so one of the things we're at right now is in a time of war, or any crisis, peacekeeping, humanitarian aid, or disaster relief, you don't have the luxury of saying, let me wait and develop new technology. You come as you are. And I think that's where we're at right now. And a lot of this, like we said, with the reduced spending and reduced funds and resources, drives us to be more efficient and take an incremental approach. So what you're going to see in this portfolio as I get into it is 2 things. You're going to see evolutionary improvements, which are incremental, but over time, cumulatively make a big transition, and you're going to see revolutionary transformation. So this is the Boeing portfolio. I'll spare you all the details about Boeing itself, but you know, we build commercial airplanes and we have a defense half of the business, and within that, within our military aircraft division, we have a vertical lift business unit. And we'll talk about each of these in turn. V-22, the tilt rotor, Apache, the Chinook, the H-6. We'll talk a little bit about future vertical lift. I won't say much about advanced vertical lift because nobody really knows what it is or wants to talk about it for obvious reasons. Starting off with the Chinook, this is absolutely the workhorse of our portfolio. It is a perfect example of an aircraft, an enduring aircraft with a great design that opens itself up to incremental improvements. So you can look at this, and it was started in the 1940s by Frank Piasecki, and I'll talk about that. And it's still going now, and the U.S. Army projects to use it not through 2060, but through 2065. And I'll show you some of the things that have changed on that aircraft compared to when it was a Vietnam-era warbird. It's not the same aircraft. I used the analogy, I think 3 years ago, it's like comparing a modern Cinquecento to the Cinquecento that you probably drove when you were kids. Okay. So just a little bit about the evolution. This is where it's come from. These are some of the improvements. And you see now it's become a special ops bird with a refuel probe and all of the bells and whistles that go with that. Started off in 1945, Frank Piasecki. The design is basically unchanged, but what allows it to still be in use today are the incremental improvements. Composites, unibody construction, the avionics, the rotors, composite rotors, and all these things, as well as sensors, as well as communications, make it a much more effective aircraft. Again, this is going to go to 2065, so I don't expect we're going to reinvent the wheel on the Chinook. It's just going to keep evolving and lending itself to modular changes. It does everything, cargo, transport, special ops, humanitarian relief. I know here in Italy you probably used it more for humanitarian relief than anything else. When you look at the configuration, what's changed on this? Basically avionics, fuselage construction. You've got some of the different comms, NAVCOM, those sorts of things. This is what's evolved over the past, and it's going to keep evolving. You're going to look at things like manned-unmanned teaming is going to become increasingly important with this. Some of our other advances for the future, and I think the next slide shows it, I would argue are not necessarily on the technology of the aircraft and what it offers in an operational scenario. It's also how we design and build it to start with in the factory. You need it cheaper, you need it quicker, you need to know that you're going to get it when you ask for it. And for us, we want to have sustainability in doing that. Just a quick note. One of the things I want to point out on this, and this applies to the Chinook, it applies to the Apache, and it applies to the V-22. So one of the things for the future that we have leveraged, not just for the U.S., but also for international customers, is we do multi-year contracts. And what that allows us to do is to do long, extended production runs for the U.S. Army or for any U.S. government customer, and we allocate X amount for international customers. And what that does is, instead of doing one-off batches of production, where you have a lot of variability in price, you may not be able to sustain the parts flow. If we can guarantee a production run of 5 years, then with our suppliers, we can get the lowest price, and we get guaranteed delivery of those parts for that full 5-year period for customers. That's another example in my mind of how you plan for the future on the developments. The factory, we put, I think it was a $150 million investment. The factory went from standing workstations to pulsing workstations. The aircraft actually moves through the factory. Again, just trying to be more efficient for the future. Okay. Each one of these modules, each one of these aircraft is built on the ones before it. CH-47F, we're doing co-production with Augusta here. We build that for the U.S. Army. That's the current production aircraft. CH-147F is also the extended range that we've sold to Canada, and we've also sold to Kuwait now. And that is, for the new build MH-47 Gulf Special Operations aircraft, will be the basis, a lot of that. It's a redundant electrical system, a lot more survivability. It's going to have DIRCM. Those things we can offer commercially with the 147F. We can offer it FMS with the U.S. government, foreign military sale for the special ops. Of course, that comes with all of the strings that the U.S. government will put on certain systems. So, and we expect that we're going to continue to evolve those capabilities. So this is just a taste on the 47. We get into the AH-64. I think it's the preeminent combat helicopter in the world right now. Over 2,100 produced. We have the multi-year contracts with this. This is going to go out through 2060 as far as operational support with the U.S. Army as well. A lot of the incremental improvements on it, and I'm going to kind of flip through these a little bit fast because I want to save time to talk about tilt rotor at the end. But manned-unmanned teaming, IFR, the different sensor packages. These are the things that the Apache E has evolved from over the last 15, 20 years. You can see some of it here, the IFR capability, the composite rotors. These are the incremental improvements in an evolutionary stance. And I don't know what the next ones will be over the next 15, 20 years, but you're going to see more of these come out. And over time, the cumulative effect will probably be almost as big as what we're calling the revolutionary changes on aircraft. The H-6I is an old design aircraft, but we took and leveraged the avionics, the weapon system out of the Apache. So here's an adjacency that you take the technology from one aircraft that's become a gold standard, put it in another aircraft. For light attack reconnaissance, that's what the H-6I does. Of note on this one, we've already done unmanned, like RUAV flights with this. We've already done trials on French naval vessels with this. Oh, sorry, it's not advancing. There we go. This is a combination of the AH-6 or the AH-6 Mike and the Apache the last 30 years. And then again, you'll see the advanced sensors. So you're going to see a lot of common themes on what I'm talking about. It's the sensors, it's the data, it's the way we communicate. That's where a lot of the efficiencies have come on traditional vertical lift. Oh, sorry. Okay, so that leads us into what I would talk about for revolutionary change. It's the tilt rotor. I've heard some of the customers call this the Swiss Army knife of aircraft. I mean, it's extremely versatile. You'll see that not just on how it operates, but the concept of how it's going to operate in the future. So it can do combat roles, search and rescue, CSAR, CASEVAC, medevac, humanitarian aid, peacekeeping, all of that. What you're seeing right now, we've got over 260,000 flight hours, 295 aircraft produced to date, and we've just had our first international sale to Japan. Going through some of the slides, again, this is a multi-year, so that allows us to guarantee production. We're about to go into multi-year 3 on this, not too far in the distant future. We're about to sign it. It's a Bell Boeing product, just to go on the record for that. The part in blue is the Boeing part, which is the fuselage, landing gear, avionics. The part in the green is produced by Bell, but it is a 50-50 arrangement with Bell Boeing. So what makes it different from the other aircraft? What you have is you have I think it's an H-60 Black Hawk silhouette in the green, and you have a C-130 flight profile or flight envelope on the right in the dark blue. And with one aircraft, you can cover the bulk of that with a tilt rotor. And one thing I'd point out on this is that envelope continues to increase. It is not limited by the tilt rotor itself. What it's limited by is the software. And as we make additional improvements to the software, that is increasing that envelope. Just the current program right now, at least for domestic customers, you've got the U.S. Marine Corps version, which is the MV-22. You've got the SOCOM version, which is the CV-22, which is normally operated by the U.S. Air Force. And then you have the U.S. Navy version, which is about to go into production. They haven't decided on the name now. I would think as a Navy guy or as an Army guy, they'd put it the NV-22, but that hasn't happened yet. But that's the domestic production we're going to do for the U.S. government. Demonstrated operational utility. It's a multi-role aircraft, multi-mission. It can do everything from sling, combat equipment. It can do carrier onboard delivery. We've already done proven trials, and we can actually we can internally load an F-35 engine to take out onto a carrier, which in Italy, for example, with your F-35s for the Navy would be applicable. We can do air-to-air refueling. It can receive fuel. It can also give fuel. We'll talk about that in a minute. Parachute drop, SAR, CSAR, and I'll touch on each of these very briefly. Designed for combat, is extremely survivable. Can carry 24 troops, 12 leaders, 2 external cargo hooks, and can carry 20,000 pounds of cargo internally loaded. Air-to-air refueling. Right now you see it in receiver mode. There's also another picture, I think, in a little bit. We've actually done touch and goes. Well, we haven't touched. We've come up in the flight envelope with F-18s behind it to test and done everything but the contact, and no problems. Search and rescue. On the search and rescue, what the V-22 does that is transformational, if you think about it, a lot of times you have to send out a helicopter or you send out a P-3 or some sort of patrol aircraft, and all they can do is they can kick out life preservers and some sort of supplies or you know, something for the survivors to float on. With the V-22, it's all done in one mission. So you eliminate assets, you eliminate time, you eliminate risk. It's also, believe it or not, being used for VIP transport for the President of the United States, for the press corps that accompanies him. This is with the lower right hand is in Chicago accompanying President Obama. On the right center, you see it parked on the Wall Street Pier in New York. So this is a VIP aircraft as well as one of the configurations. Designed for shipboard deployment, the U.S. Marines use this extensively. Just from a maritime perspective, it can reduce your aviation assets, it can reduce fuel needs, which also, I think, Commander Casapieri made the comment about the space on the ship as being precious. So if it uses less fuel and uses the same kind of fuel that's already used by other aircraft, that's an advantage of it. So where's it going in the future? And so I think this slide is kind of the heart of this presentation. So you've got the aircraft itself, which is transformational on what the aircraft can do. And then what else can you have it do? And that comes with roll-on, roll-off kits, at least is the concept. And we've already developed some of these. So the search and rescue, the air-to-air refuel, the VIP transport, these are the present here in the green. The yellow are the things that are emerging or working on right now. So recon surveillance, C4ISR, airborne early warning. And then if you look forward, it could have maritime patrol aspects. Let's see, what were some of the others? Maritime patrol, and then you can actually have the air-to-air refueling to give fuel, excuse me. And I would also point out on this, it's a Bell-Boeing project, so most of the production of the aircraft is already allocated. But what's not allocated, and where we would look for partners, national industry partners, would be to work on the roll-on, roll-off kits. That's where new developments are going to come for this aircraft quick and furious, because it's easy to do the kits, and they can apply to more than one aircraft. It's modular. I think going back to the plug and play. If it could fit on this, and it could fit on another aircraft, it could fit, you know, you can scale it up or down for different types of aircraft. Just another example, the carrier onboard delivery concept for the F-35s, search and rescue, medevac. And one thing I'd point out on medevac that the V-22 transforms, we talked about the golden hour. I think Andy in the TV mentioned that. You can actually do triage on a V-22 you can't do on a helicopter because the vibrations are too much. But when this goes into horizontal flight, you can actually do much more delicate medical procedures, which is, again, going to increase survivability of troops. This is the picture I was mentioning of the F-18, or the Super Hornet. So here's an example of how this has been transformational. So this is a traditional helicopter self-deploy. This was something we did for the Japanese customer to look at. And this is what it's going to look like when it's done by V-22s. So, sorry, I just like the dramatic effect on this one. Big difference. Okay. Give you a couple scenarios of what this has enabled us to do already in missions for our customers. So you got a mission with a downed aircraft in Kandahar, or near Kandahar, downed aircraft, the crew was under attack, they tried to fly other aircraft to get through, and they couldn't do it because of dust and because of altitude. And then they ended up sending 2 V-22s that went in, they went over 15,000 feet AGL to go across mountains. They rescued 32 people, and they returned to base in under 4 hours. Same thing here. Don't have details on this mission, but round trip mission, 265 nautical miles in 45 minutes. So I tend to think of the V-22 as still a new capability. We're just now starting to really talk about it in these discussions. But it as revolutionary as it is, has already become a proven capability. It's got 260,000 flight hours. And what's really amazing is over 50% of those were put on the aircraft in the last 3 years. Over 50%. So what that tells me is the customers are just now beginning to explore the potential of the aircraft and where it's going to go. The other thing that the V-22 does, and it's not on the slide, but one of the other things, it's not just data packages, it's not just sensors for what you do operationally. It's the data for how you sustain the aircraft. Other than maybe the F-35, the V-22 is one of the most data-driven sustainment packages in the world. We collect real-time data that we submit back, or we collect from the Navy and from the U.S. Marine Corps and from the Air Force. And that goes into a database, not just for those customers, but for all the international customers. So there's real-time troubleshooting, there's data collection on trends. Again, to try to make the operational availability, we want to increase that and reduce the life cycle costs. And I think that this is going to be a gold standard in that regard. Okay, bear with me because I know that everybody's sleepy after lunch. So can't really say a lot about the JMR right now. JMR in concept is supposed to have, I think it was supposed to have common wings, rotors, drives, and engines. And it's projected to develop over 4,000 aircraft. The reality is it's still a DARPA project that's ongoing. You've still got Boeing, Sikorsky, Bell, all with different demonstrators. But going back to the point about technology investment in states, that's going to drive the future. The point I made 3 years ago is the designs that we're looking at. A lot of these we think are new, but you can trace them back to the 30s, 40s, 60s. And it's going to be the incremental improvements that enable them. So I'll wrap up. I think that overall we have a good portfolio. It's relevant to what's going on today, and I think it's well poised for the future to evolve. I think that the evolution on this, we talked about evolutionary, revolutionary, it's going to take multiple technologies. A good example, fighter aircraft, the Germans in World War II when they were developing them, it took advances in metallurgy to keep the engines from melting. I mean, those kinds of small things are what going to enable us to make other leaps. What transformational leap we have revolutionary, in a revolutionary sense, if you know what it is, let me know, I'll buy stock in that company. So I'd like to thank you for your time. I think that the future, in summation on this, the future goes into, or future development of rotary wing vertical lift goes into not just the operational capability, but it goes into the design, it goes into the contracting methods, the production methods, the sustainment methods, and the long-term upgrade plans. That has to be planned into the aircraft from the beginning. So this is our perspective on it. I'm open to any questions.